Okay everyone, let's begin our discussion over the questions from probability. Now specifically when probability is concerned, the questions on dice and the questions on cards hold great importance. Okay, when the question is about coming up in your paper, the questions coming up in your papers, and the dice problems and the card problems are specifically important. So let's look at this question from probability on dice. As you can see, there are two dice, one blue and one grey. They are thrown at the same time. So simultaneous throw of two dice is happening. Write down all the possible outcomes. What is the probability that the sum of the two numbers appearing on the top of the dice is 8, 13, less than or equal to 12? Okay, so when you are throwing two dice, there is an outcome from 1 to 6 coming up on the first die, and there is an outcome from 1 to 6 coming up on the second die. When you add those numbers, you are getting an 8 or a 13 or a number less than or equal to 12 is what the question is trying to say. So actually, first of all, when two dice are being thrown, it is a random experiment. The random experiment here is the simultaneous throw of two dice. What would be the sample space? What all would be my possible outcomes? In order to get that, what you do, you write all the possible outcomes of the first die horizontally and all the possible outcomes of the second die individually vertically. So you write 1, 2, 3, 4, 5 and 6. These are the 6 possible outcomes which can come up on the first die, or you can just say the blue die. So I have written if only the blue die is concerned, when I roll the blue die or toss the blue die, I am going to get either a 1 or a 2 or a 3 or a 4 or a 5 or a 6 on the face of the blue die. Now comes the question of the grey die. When I throw the grey die individually, I again get outcomes from 1 to 6, so that I write vertically. 1, 2, 3, 4, 5 and 6. Now both are being thrown together. So you can get 1 on the first die and 1 on the second die. That outcome you write like this. 1 on the first die, 2 on the second die. 1 on the first die, 3 on the second die. 1 on the first die, 4 on the second die. 1 on the first die, 5 on the second die. 1 on the first die, 6 on the second die. So let me say this I am naming as the outcomes of the first die, and this I am naming as the outcome of the second dice. Is it clear? So then you can get 2 on the first die, 1 on the second die. Fine. 2 on the first die, 2 on the second die. 2 on the first die, 3 on the second die. 2 on the first die, 4 on the second die. 2 on the first die, 5 on the second die. 2 on the first die, 6 on the second die. Or you can get 3 on the first die, 1 on the second, 3 on the first, 2 on the second, 3 on the first, 3 on the second, 3 on the first, 4 on the second, 3 on the first, 5 on the second, 3 on the first, 6 on the second. Or you can get what? 4 on the first, 1 on the second die, 4 on the first, 2 on the second, 4, 3, 4, 4, 4, 5, 4, 6. Now these ordered pairs are representing the possible outcomes which can come up in the simultaneous throw of two dice. That means any A, B ordered pair that you are writing as one of the possible outcomes, what is it representing? The first coordinate is representing the outcome on the first die, and second coordinate is representing the outcome on the second die. It's just that we are writing it in an ordered pair format. We are representing the outcome in this fashion, but you should know what it is actually representing, okay, what it is interpreting. 4 on the first die, 2 on the second die represents one possible outcome in the simultaneous throw of two dice. Still we are left with some possible outcomes. You can get 5 on the first die, 1 on the second, 5 on the first die, 2 on the second, 5 on the first die, 3 on the second, 5 on the first die, 4 on the second, 5 on the first die, 5 on the second, and 5 on the first die, 6 on the second. Okay, and last is you can get 6 on the first die, 1 on the second, 6 on the first, 2 on the second, 6 on the first, 3 on the second, 6 on the first, 4 on the second, 6 on the first, 5 on the second, and 6 on the first, 6 on the second. These are your 36 possible outcomes in the simultaneous throw of two dice. And that is how you obtain them without even missing a single one. So if you write capital S equal to 1 comma 1 comma this ordered pair comma this ordered pair comma this ordered pair, and so on so on so on till this ordered pair, and you write all these ordered pairs in a set within curly brackets and keep it equal to capital S, that is your sample space associated to this random experiment of tossing a pair of 2 dice simultaneously together. Is it understood? So this happens to be your sample space. This is how you obtain the sample space, and I told you how do you write the sample space. You write capital S equal to all these ordered pairs separated by commas, and then you close the curly brackets. Fine, that is your sample space. So write down all the possible outcomes. We have written all the possible outcomes. What is the probability that the sum of the two numbers appearing on the top of the dice is 8? So let's see. Probability of event A. Event A is the event when the sum of the two numbers which appear on the top of the die is 8. So I am keeping this as my event A. Okay, I am not writing, you can write it down. So what is the probability that you are going to get two numbers on the two die such that when you add them, the sum is equal to 8? That is what? Total number of favorable outcomes to this event upon actual total number of outcomes. So entire total number of outcomes is 36. That is not a problem. So denominator is going to have 36. Out of these 36 total number of possible outcomes, how many are favoring my event A? How many are those outcomes in which the sum of the two numbers which appear on the two die is adding up to give you 8? Well, if 1 comma 3 comes up, that means 1 on the first die, 3 on the second, then 1 plus 3 will be 4, which is not equal to 8. So this possible outcome is not favoring my event A. But if I talk about 2 comma 6, then 2 on the first die, 6 on the second gives me 2 plus 6, that is 8. So if this outcome comes up, then this is definitely favoring my event A. After that, you can clearly see this is also favoring event A because 3 plus 5 is 8. This is favoring event A because 4 plus 4 is 8. This is favoring event A because 5 plus 3 is 8. And this is favoring event A because 6 plus 2 is 8. Out of the 36 possible outcomes, only these 5 outcomes are actually the outcomes which if they come up, they are going to favor my event A. That means if this comes up, then event A will happen. If this comes up, then event A will happen. If this comes up, event A will happen. If this comes up, event A will happen. If this comes up, then I will be getting that the sum of the numbers that I obtained on the two dice is equal to 8, so event A will happen. So I have to see how many possible outcomes out of total outcomes are there which are going to make my event A happen. That are my number of total outcomes which are favoring my event A. So out of 36, only 5 are favoring event A. So 5 by 36 is the probability of occurrence of event A. You can check, there is absolutely no other possible outcome which can favor my event A. Okay? After that, you have what is the probability that the sum of the two numbers appearing on the die is equal to 13. So let me say that event I am keeping as event B. I have to find probability of event B. Out of total of 36 outcomes, how many are favoring my event B? How many are those outcomes which are representing two numbers on the two die such that when you add them, you get 13. See, the minimum sum that you get when the two numbers pop up on the two die, the minimum sum of those two numbers which you get is 2. You get the sum as 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, that is the sum. Then 5, 6, 7, 8, 9, 10, then 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, 12. So the minimum sum is 2 and maximum sum is 12. That means absolutely there is no outcome which you will be getting in the simultaneous toss of two dice such that when you add the two numbers on the two dice, you're going to get it 13. The max that you can get is 12 and the min that you can get is 2. So there is absolutely no possible outcome which if come up is going to make my event B happen. There is no outcome out of all these 36 which are my all possible outcomes. There is no outcome which is favoring my event B because there is no outcome which is giving me two numbers on the two die which when I add I get a 13. The max that I can get is 12. So absolutely no outcome is favoring my event B. Therefore, 0 is the number of outcomes which favor event B. So, the probability of occurrence of event B is 0. I say B is an impossible event. It can never ever occur. If I talk about C event, that means I wish to find the probability that the sum of the two numbers appearing on the top of the two dice is less than or equal to 12. Either the sum is 12 or the sum is less than 12. If you can focus on all these possible outcomes, the sum begins from 2 and goes on till 12. So, out of these 36 outcomes, any of the outcome which comes up is going to make my event C occur. Why? Any outcome you pick up, either the sum of the two numbers will be 12 or it will be less than 12. Absolutely no outcome is violating or going against this statement. Any out of these 36 possible outcomes, if pops up as an outcome, is going to make this event C occur or happen. And that is why out of these total 36 possible outcomes, all the 36 are favoring my event C. Therefore, the probability is 1. We say such events are sure events. They will definitely occur. In any trial of this experiment of simultaneous toss of two dice, event C will definitely occur, and in any trial of this simultaneous toss of two dice, event B will never occur. This is an impossible event, has probability 0, chances of occurrence is 0, and this is C, it has the maximum probability. You know, probability lies between 0 and 1. So, this has probability 1, means it is a sure event. It will definitely occur in any trial of this experiment. Is it clear? I hope the context is very clear. Of course, you can define your event A, B and C. Write the number of favorable outcomes. To A is 5, and then to B is 0, and to C is all 36. These statements you can write, and total number of possible outcomes is 36, and that is why you are getting these as the respective probabilities. Is it clear? Let's move to the next question. Again on dice, as I told you, questions on dice hold pretty much more importance as compared to the other categories of questions on probability. Now it says a single die is thrown. So obviously when we've dealt with two dice, then dealing with single die should be a cakewalk. It should be a walk in the park. A die is thrown once, find the probability of getting a prime number. So if a die is thrown once, my random experiment is that I am throwing a single die. My random experiment is that I am throwing a single die. Now, what will be my sample space if I am throwing a single die? Then either I can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So, my total number of possible outcomes is 6. This means number of members in the sample space. Number of members in the sample space, which is also called cardinality of the sample space, is 6. If you don't want to get to this term, you can just ignore it. The sample space is this. These are my 6 possible outcomes. Out of these 6 possible outcomes, I have to find something. I actually need to find the probability of getting a prime number. What is the probability that a prime number comes up when you toss a single die? Well, the total number of possible outcomes is 6. Out of these 6 outcomes, which are those outcomes which if they come up, they are going to make my event A happen? Well, if the outcome is a 2, then definitely it is a prime number, and therefore my event A will happen, right? After this, if 3 comes up as an outcome in my throw of this single die, out of these 6 outcomes, if 3 comes up as the outcome, then my event A will happen, right? And if 5 comes up as the outcome, then also my event A will happen. So out of these 6 possible outcomes, only 3 possible outcomes are there, which if they come up in any trial of this performance of the random experiment of throwing a single die, are going to make my event A occur. So these 3 outcomes are favoring my event A. Out of 6, 3 are favoring A. So 1 by 2 is the probability of occurrence of event A. Similarly, if I define this event as event B, that means find the probability of getting a number lying between 2 and 6 strictly, then what is the probability of occurrence of B? Again, total number of possible outcomes is 6. Out of these 6 possible outcomes, how many are there which are favoring my event B? That means which are those possible outcomes which if they come up as an outcome in any trial of the experiment, then they are going to make my event B happen. Well, I am saying the number should lie between 2 and 6. 3, 4 and 5 are the only 3 outcomes which, if they come up, are going to make my event B occur. 1, 2 and 6. These 3 outcomes which, if they come up, are not going to let my event B happen, because 1 is not a number lying between 2 and 6. I want numbers lying strictly between 2 and 6. Strictly greater than 2 and strictly less than 6. 2 is not strictly greater than 2. 6 is not strictly less than 6. So 1, 2 and 6 are not going to let my event B occur in any trial of the experiment, but 3, 4 and 5, if they come up as the outcome in any trial, in that trial event B will occur. So out of these 6 possible outcomes, 3 are favoring event B. So again, 1 by 2 is the probability of occurrence of event B. Then what is the probability of the occurrence of third event? I am saying that what is the probability of getting an odd number? So you can clearly see odd number is 1, 3 and 5. So out of these 6 possible outcomes, if these 3 outcomes pop up in any trial, then in that trial event C will occur. So out of the 6 possible outcomes, 3 are favoring the occurrence of event C, and therefore again 3 by 6, that is 1 by 2, is the probability of occurrence of event C. So all the 3 events have the same probabilities, but actually they are standing and representing something else. This is representing a prime number's occurrence. This is representing the occurrence of a number lying between 2 and 6. This is representing an odd number occurrence, but all these 3 events have the same probability of occurrence. Cool enough? Let's talk about the next question. Now it's on cards. Okay. So I hope the concept of cards is very clear to you. If it is not clear, let's revise it for one last time. Okay, and then we're going to deal with this question. So in your well shuffled deck of 52 cards, you actually have 2 categories. One is of red cards and one is of black cards. Fine. Now there are 2 suits of red cards and 2 suits of black cards. 2 suits of red cards and 2 suits of black cards. You have diamonds which look like this, obviously red color, and you have hearts which look like this. There are 26 red cards, 13 diamonds and 13 hearts. In your black cards, there is spade and there is clubs. Black cards are also 26 in number. 26 plus 26 is 52, but the distribution is what? That 13 spade cards and 13 club cards. Now what are these 13 cards in each suit? There are 4 suits, you can see. Suit 1, suit 2, suit 3, suit 4. There are 4 suits. You have Jack of diamonds, Queen of diamonds, King of diamonds. These 3 are called face cards of diamonds. And then you have Ace, 2, 3, 4, 5, 6 up till 10 of diamonds. Similarly, you have Jack of hearts, Queen of hearts, King of hearts. Again, these are my further 3 face cards. And then you will have Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10 of hearts. So these are my 13 cards of hearts. Similarly, you have Jack, Queen, King of spades. These are again my face cards in spades. And then you have Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10 of spades. Similarly, you have Jack, Queen, King of clubs. These are my face cards. And you have Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10 of clubs. So in all, you can see that there are 12 face cards in a well shuffled deck of 52 cards. 3 plus 3 plus 3 plus 3. Okay, 4 aces you have, right? Ace of diamonds, ace of hearts, ace of spades, ace of clubs. Now that this is understood completely, let's tackle the question on probability on cards. It says that one card is drawn from a well shuffled deck of 52 cards. That means the random experiment that you're performing is withdrawing one card from a well shuffled deck of 52 cards. So how many possible outcomes are there? When you are drawing one card, that one card can be any card out of the available 52 cards. So what are all the possible outcomes? There are 52 possible outcomes, right? Because there are 52 cards, any card can be withdrawn when you are inserting your hand in the well shuffled deck of 52 cards and drawing a card. Any card can come out, and therefore there are 52 possibilities of that card coming out. So total number of outcomes, number of members in the sample space is 52. I can't write the sample space. In the sample space I will write this only. What will I write? What is the possible outcomes? Jack of diamonds, queen of diamonds, king of diamonds, ace of diamonds, and so on. 10 of diamonds, jack of hearts, queen of hearts, king of hearts, and so on till 10 of hearts, jack of spades, queen of spades, and so on till 10 of spades, jack of clubs, queen of clubs, and so on till 10 of clubs. These are my members sitting in the sample space. So how many members are there in the sample space? 52. Of course, when you start writing the members in the sample space, you can write all of this, but there is no point doing that, because in the computation of probability, the denominator happens to be the total number of members in the sample space. And of course, you have the members written over here. If you know what is the structure in the cards, then you don't need to write the members of the sample space. Just by that knowledge, you can proceed ahead with the question. So let's see. If one card is being drawn, what is the probability of getting a king of red color? So you want red colored king. Out of the available 52 cards, which are my possible outcomes, which are those possible outcomes, or which are those cards which are going to let this event occur? So let me say this is event A. Which are my, out of 52 possible outcomes, which are my possible outcomes which are going to let this event occur? Now please try to get the structure. You want a king in red color. Red color. You can see there is a king of diamonds and there is a king of hearts. Out of the 52 cards, only these two cards are king of red color. So out of all the 52 possible outcomes, if these two outcomes pop up, then and only then will this event A occur. So out of 52 possible outcomes, only 2 are my outcomes which are favoring the occurrence of event A, and therefore probability of occurrence of event A is 2 by 52. Let's talk about the next one. Face card. What is the probability of getting a face card? Well, out of total number of possible outcomes, which is 52, how many are favoring the occurrence of event B? That means out of the 52 cards, how many cards, or which are those cards which, if come up as the outcome, are going to let my event B happen? That means they will be face cards. So I just told you that there are 12 face cards, these 3, these 3, these 3 and these 3. These 12 face cards, if they come up as outcome in any trial of this experiment of withdrawing one card from a well shuffled deck of 52 cards, are going to let my event C occur. Is it clear? And therefore, these are the 12 possible outcomes which are favoring the occurrence of event B, and therefore 12 upon 52 is the answer of probability of occurrence of event B. Then I have a red face card. So you want a face card, that too of red color. So red colored cards are these, 26 red colored cards are there. Out of these 26 red colored cards, a red face card. So these 3 are red face cards and these 3 are red face cards. Total number of possible outcomes is 52, out of which these are the 6 possible outcomes, which if they come up as outcome in any trial of this experiment, then they are going to let this event C occur. So out of 52 possible outcomes, 6 possible outcomes are favoring the occurrence of event C. What are these 6? Either you get Jack of diamonds, queen of diamonds, king of diamonds, jack of hearts, queen of hearts, king of hearts. These 6 cards are my possible outcomes which are favoring my event C. So 6 by 52 is the probability. After this you have the jack of hearts. Let me name this as D. the jack of hearts. So hearts is specific, jack is specific. Only one jack of hearts is there. So out of the total of 52 cards, only if this one card pops up as the outcome in any trial will this event D occur. So only one outcome out of the 52 is favoring the occurrence of event D, therefore 1 by 52 is its required probability. Then it says a spade. What is the probability of getting a spade? Now out of the total of 52 outcomes, how many are the outcomes which are favoring the occurrence of a spade? You know that these are the 13 outcomes which, if they come up, are going to make a spade occur. Fine. So out of 52, 13 cards are there which are spade cards. If they pop up as the outcome when I am withdrawing a card from this well shuffled deck of 52 cards, then my event E will occur. So 13 outcomes are favoring the occurrence of event E. So 13 by 52 is its required probability. After this you have this last event. Let me say this is F. I want queen of diamonds. What is the probability of getting a queen of diamonds? Let's move to diamonds. Queen of diamonds. Out of these so many 52 cards, only one card is there, that is queen of diamonds, which if comes up as the outcome in any trial is going to make this event F occur. So out of the total of 52 possible outcomes, only one is favoring event F. So 1 by 52 is this required probability of occurrence of event F. Is it understood? Please mind it, the questions on cards and dice are specifically very important, and that is why this concept of cards was revised with you in this course. Is it clear? So that any question regarding any of the events occurrence related to cards is asked to you, just if the structure, the distribution, the numbers, all these designs, the functions are clear to you, then you will be able to answer any query based upon cards. Okay? Now let's move forward and look at the next question. Again the question is on cards. This time what is it trying to say? Let's see. It says that in total you have 5 cards. What are those 5 cards? The 10, the jack, the queen, the king and the ace of diamonds. Only these 5 cards are present with you. You don't have 52 cards. You have of the category diamonds, you have the 10 of diamonds, the jack of diamonds, the queen of diamonds, the king of diamonds and the ace of diamonds. Only these 5 cards are the total cards that you have. They are well shuffled with their face downwards. That means you are not able to see which card holds which symbol. One card is picked up at random from this well shuffled deck of 5 cards. So what is your sample space? Your sample space is, if these are your 5 cards and you are picking up one card from these 5 cards, then either you can get the 10 of diamonds or jack of diamonds or queen of diamonds or king of diamonds or ace of diamonds. So total number of members in the sample space is 5. Easy enough? What is the probability that the card is a queen? So card being a queen, I am defining as event A. What is the probability that the card is a queen card? So out of the total of 5 outcomes, what is the probability that the card is a queen card? Means out of the total of 5 possible outcomes, how many outcomes are there which are favoring the occurrence of event A? That means which card should come up in a trial so that in that trial event A occurs. Of course, queen of diamonds should occur, right? So out of all of these, if this outcome occurs, then and only then will this event A occur. Queen of diamonds is what the question is asking for. So 1 upon 5 is the required probability of occurrence of event A. Because out of these 5 outcomes, which are my in total possible outcomes, only this outcome is favoring event A. Next part says, if the queen is drawn and put aside, now what is the probability that the second card picked up is an ace or a queen? See, what is happening? So previously I had these 5 cards. So in total there were 5 possible outcomes. So out of 5 I was finding the number of outcomes which are favoring event A. Now the question says this queen has been picked up and moved aside, not replaced back. So now in total that I have cards which have their face downwards are 4 cards. So now my new sample space is 10, Jack, King and Ace. I cannot pick up a queen now because it has already been kept aside after being picked up. Queen was taken out and it was kept aside. So now I have kept aside the queen. Queen is out of this track now, out of this list now. So now I'm only left with 4 cards. I'm left with 10 of diamonds, Jack of diamonds, King of diamonds, Ace of diamonds. Now whatever I will be picking up, now my random experiment has changed. Now the random experiment is picking up 1 card from these 4 cards. Now my total number of possible outcomes are 4. Either I can get a 10 of diamonds or Jack of diamonds or King of diamonds or Ace of diamonds. I can't get a queen now because it has already been kept aside. Is it clear? So now my new sample space is this. So let me name this as S dash. So number of members in the new sample space is 4. These are my now new possible outcomes. Now I have to answer my question corresponding to this. That now tell me the probability once the queen has been kept aside, what is the probability that you get an ace card? So getting an ace card, let me say I am defining as event B. What is the probability of occurrence of event B then? Out of in total 4 possible outcomes, how many possible outcomes are favoring my event B? That means which outcome if comes up? Which outcome if comes up is going to mean that ace is popping up. Of course, out of all these, only 1 ace of diamond cards is there, right? So out of these 4 possible outcomes, only this outcome, if it comes up, is going to favor my event B. So 1 by 4 is the probability of occurrence of event B. Now I say that the probability of getting a queen card, I have to find out. So getting a queen card, after 1 queen card has been withdrawn and kept aside, I am taking as event C. What is the probability of occurrence of event C? That means out of the available 4 possible outcomes, you can either get a 10 of diamonds or a Jack of diamonds or a King of diamonds or an Ace of diamonds. Out of these 4 possible outcomes which you can now get once 1 queen card has been kept aside, it is out of the list. What is the probability of getting a queen card? Like, come on, if you have already kept aside your queen card, how can you now get a queen card when you don't have 2 queen cards? There was only 1 queen card. We took it out and kept it aside. Now I'm not left with any queen card. So how can I say that there is some possible outcome which is going to make my event C occur? If in any trial this comes up, event C will not occur. This comes up, event C will not occur. This comes up, again event C will not occur because it's not a queen card. This comes up, again event C will not occur because this is also not a queen card. So out of the 4 possible outcomes which can occur, none of them are favoring my event C. That means there is absolutely no possible outcome which is favoring my event C, and therefore 0 upon 4 is the probability of occurrence of event C, which is 0. And this is but obvious now. Come on. If you have already withdrawn the queen card, how can you now get a queen card if there was a single queen card in your collection of 5 cards? If there was a single queen card in your collection of 5 cards and that queen card you have withdrawn and kept aside, now there is absolutely no chance of occurrence of queen card, right? And therefore the chance of occurrences of queen card being withdrawn is 0. That means it is an impossible event. Is it clear? We come up to an end over the discussion of questions for this session. I'll be seeing you in the next lecture. That's it from my side. Thank you.